let's get going with this evening's lesson, and we're going to carry on. So last week, Thursday, we started some application questions or test type questions, and we're going to step it up this evening. Okay, so I hope you've got your thinking cap on. I'm sorry to do this to you on the first day of term, but we are going to really think hard this evening. Just remember, it's no big deal. Approach it lightheartedly, and just try something. Even if you don't immediately know, throw some ideas around. There we are at home, see what you come up with. Okay, so nothing ventured, nothing gained. No stress here. Okay, we're just going to play with the maths. Okay, right, so let's see. First question we've got, actually, let's do our reading phase thing. Read through the question, and when you are done, pop your nerdy reading face in the chat so that I know you've gone through the questions and have read everything. Okay, well done. Got many reading faces, so let's see. We're going to start off, it says we have triangle ABC with those vertices, so we've got points to go with that. And we are going to calculate the gradient of line AC. Off you go. As soon as you have an answer, pop it in the chat. The gradient of AC. Hi, Tsioma. I hope you had a good first day at school. We are doing question 3.1.1, the gradient of line AC. No problem, Bukhle. We all know about the load shedding. Hi, Ntandakazi. Okay, we've got some answers in the chat for the gradient. Let's see if these people are right. So we're going to go 1 minus 3. You guys better watch me today because I have been mixing up my coordinates the whole afternoon. Miss Coco has had to keep a close eye on me. So we get 4 over minus 2. So our gradient is minus 2. Okay, good stuff. Now, let's go to 3.1.2. Determine the equation of the line that is perpendicular to AC and passes through A. Okay, so one bit at a time. What is the gradient of the line that is perpendicular to AC? If AC is minus 2, what will the gradient be of the line that is perpendicular to it? We did that 3 lessons back. Second lesson you guys did was with the gradients. You guys are changing signs, but there's another thing you need to do. Come, let's get the answer. Perpendicular. I'm going to say one word, reciprocal, because we are changing. I can see that we are changing the signs, but we are not doing the other part. Look at Miss Coco. She's giving you lots of hints. It's not -2. It's not 2. Come, give me hope, someone. Some people, it was almost there. Almost. There we go. Robin Lee's got it. Well done, Robin Lee. And wait, Zandile also had it. She wrote it out. And Fumisa. Yeah, well done. Okay, guys, so one more time. Let's watch this movie again. Let's do the rerun of the perpendicular lines. So if the gradient of AC is -2, we need to change the sign. Yes, make it positive, but then we have to also do the reciprocal. So if it's -2 over 1, then it must be 1 over 2. So that's the gradient of the lines that are perpendicular. So that's just the gradient. We also need the equation of the line that is perpendicular to AC and passes through A. So if we are doing the equation, it will be a half x plus c, because y equals mx plus c for a straight line. And with analytical geometry, this stuff can be thrown in. You can be asked about lines and the equations of lines when you do analytical geometry. So be ready for it. It passes through A, so we must sub in point A. Y is 1, x is -1 plus c. So we multiply that out. A half times a -1 is -1/2 plus c. And then we get c by itself. We're going to take the -1/2 over to the other side by adding it. So it's going to be 1 plus 1/2 gives me 1.5 is equal to c. So the equation of this line is y is equal to a half x plus 1.5. Okay, right, just give me a thumbs up if you understand that part about finding the equation, and really make big notes for yourself about the gradient of the line that's perpendicular. Okay. Do I only have 2 people with a thumbs up? I used 1 and -1 because we sub in point A. Guys, we're just finding the equation of a straight line. You've been doing this since grade 9. It's just here now in analytical geometry. The analytical geometry part was for you to figure out that because the lines are perpendicular, the gradient of this line that's perpendicular to AC is a half. And read the question carefully. It is perpendicular to AC and it passes through point A. How did it become a mixed fraction? Okay, so we sub in point A because this line passes through point A over here. I'll forgive you because this is the first day. Read carefully through it, guys. Okay, so we sub in, y is 1, x is -1. The half comes from the fact that the gradient is a half. Okay, so here y equals mx plus c. And then we multiply a half with -1, that gives me -1/2. And then we need to get c by itself. We are solving for c. And we've been solving equations since grade 8. So we should know that to get c by itself, you have to get rid of the -1/2. How do we get rid of it? We add it. If I add it on one side, I must add it on another side, on the other side as well. So 1 plus 1/2, last time I checked, is 1.5. So that's why it is 1.5. So c is 1.5. Okay. 3/2 is fine. Any other questions in the chats? Right. Okay. Let's carry on. Let's do M as the midpoint of AB. M as the midpoint of AB. Determine the coordinates of M. M is the midpoint of AB. Okay, off you go. We've done this many times. Pop your answer in the chat as soon as you have it. The coordinates of M, the midpoint of AB. Misa's quick, Toklo as well. And this, oh no, Sanda was saying about the previous question. Let's get some more answers. Take the x coordinates, add them together and divide them by 2. And then you do the same with the y coordinates. Yes, Tiamo, very quick. We got to be quick. We got to be fluent with this. It must flow. That's why you practice, so that you can be quick. So that you have time to spend on the other questions that you need more time for. Okay, everybody, be careful of copying answers from other people, because why are we writing our coordinates with a comma? That looks like 3, 2. We write coordinates with 3 semicolon 2. Okay, so be careful of that and do your own work. Okay, so -1 plus 7, -1 plus 7 divided by 2, and then 1 plus 3 divided by 2. Give me the x and the y coordinates of the midpoint. So M in this case is 6/2 is 3 and 4/2 is 2. Okay, well done. And lastly, let's calculate the length of AC. Show all working. So let's do the length of AC. That should be no problem. We've done that many times now. 3.1.4, and you've done it in your quiz and you did very well with it. So AC, we're going to do x2 minus x1 squared plus y2 minus y1 squared. Since they do not specify, you can leave your answer in surd form or in decimal form. So pop it in the chat as soon as you've got it. For those of you who are taking a little bit longer, don't stress, just don't look up at the chat until you are done. Okay, so only look at the chat when you are done. And those of you who are being very quick, make sure that you're actually writing down and not just putting it into the calculator. You've got to get into the habit of writing the steps down because, oh, AC, you need the coordinates. Like that. Okay, so we have a few answers already. You should get 4,47 or 2 root 5. Make sure that you got that. If not, check where you made your mistake so that you can correct it. So we do -1 squared plus 1 minus 3 squared. And then AC is 4,47 or 2 root 5. Okay, well done, everybody. Okay, let's move on. Let's get to our next one. Here we go. Okay, very similar to the previous question. If you just read with me, because I'm going to actually leave you alone for a little while with this one so that you can try it on your own. So determine the gradient of PR. And then in 3.2, we're going to determine the equation of a line parallel to PR passing through Q. So we know how to do that now. And we just need to remember about parallel lines. Parallel lines, the gradients are the same. And then we're going to do the length of RQ. No brainer. We've done that many times now. And then given that Q is the midpoint of line SR, determine the coordinates of S. So that one's going to make you think a little bit. And then the last one, we're going to determine if PR is perpendicular to RQ. Okay, I'm going to leave you for a while with this. We'll check back in about 4 minutes to see where everyone is with 3.1, 3.2, and 3.3. Okay, but I'm leaving the whole question up so you can work on it if you're working fast. Okay, CJ, we do screenshots at the end of the lesson. So if you need something, then yeah, just remind me at the end of the lesson to put it back up. Okay, but for now, everyone, we're going to work on our own for about 4 minutes and tackle this question. Okay, so hold answers, don't do answers yet. If you have a question, pop it in the chat or put your hand up. You can ask questions while you are working, all right? Also, pop a question to Miss Coco. Look at her, she just wants a question. She's dying for someone to ask her a question. So just send her a question. Oh, yeah, Tiama, you were on the leaderboard. You missed it, but you can watch the recording. Now, our time's not up yet, so just hold your answers for a few more minutes. Tiamo. No, no, no. I expect you to be done at least up till 3.3. Yes, guys. So that's why if you're on 3.4 and you're thinking about that already, so Q is the midpoint. Remember, just play with the maths. Don't stress, don't panic. Just see. So what does it actually mean? You know, how can we make sense of this? So given that Q is the midpoint of line SR, so R is here, and here's Q. So then SR could be like that. We don't know where S is, but it's there somewhere. We must figure out what the coordinates of SR are. We did that when we did the missing coordinates. Yeah, so it should be hanging out somewhere there. I think it would have been easier if you had the diagram in front of you on a piece of paper. But yeah, just see what can we do? How can we figure this out? But we have done something like this before. Right, guys, are we ready? Let's post answers for the first one, for 3.1. Yes, Onako was just waiting for me to make the call. Here we go. Onako says -4/3. Nyasha, Isa, I agree. 3.1, the gradient of PR is -4/3. We go 3 plus 5 over -12 plus 6, and that's going to simplify to -4/3. Wonderful. I see lots of you agreeing. We've got the gradient in the bag. Okay, determine the equation of a line parallel to PR passing through Q. Okay, who's got that equation for me? Pop it in the chat. Tiamu says -4/3x plus 11/3. We just need an x there after the -4/3. Anyone else? Come grade 10s. I'm waiting for some answers here. Siamu can't be the only one who got that far. Yes, Yenzi, let's hear the question. Just own it, Siamu. You're the only one. You're the only one who could do it. Yenzi, what's your question for this one? The line is parallel to PR and it passes through point Q. Okay, Yenzi, while you type your question and stuff, I'm going to start. So if it is parallel, here's the question. When calculating this, do we use the mx plus c? Yes, it's a straight line. That's exactly what you do. You use y equals mx plus c. And like I said earlier, in this, in analytical geometry, you can be asked about straight lines as well, but it's exactly the same. The part that you must know now in analytical geometry is that if it is parallel, its gradient is going to be the same as PR. So it's minus 4/3x plus c. And then it passes through point Q. So we're going to sub in point Q. So if we sub in point Q, y is 1 and x is 2. And then we're going to solve for c. Okay. I'm a little bit disappointed that there wasn't anyone else who got this one right. So Siamu can definitely take the what's it called, Ms. Kaka? Brownie points for this one. Okay, and then we're going to multiply minus 4/3 times by 2. It's minus 8/3 plus c, and we're going to solve for c by adding the negative 8/3 on both sides, and then you get 11/3. It's equal to c. Final answer is minus 4/3x plus 11/3. Rightio. Okay, guys, this is not going to go away. So if you are asking, if you are not sure what to do, then like Yenzi, you must ask a question, either from myself or Ms. Coco, or pop it in the chat. Okay, let's do the length of RQ. Sandile says it's 10 units. Muneti says it's 3.6. I wonder who is correct. We times by 2, CJ, because we are substituting in point Q. The coordinates of Q are 2 and 1, and we substituted in at this step. Okay, everyone else is doing the distance, and I agree it is 10 units. Okay, I'm not going to do the whole thing again. It looks like everyone knows how to work out distance formula. Okay, and then 3.4, pop your answers in the chat if you've got answers for 3.4. 10 and 7, nice, Sandile. Anyone else? Kamugelo says 8 and 6, good try. 10 and 7, 10 and 7, Kloklo, Bushola, nice guys, good tries. So we've got Q is the midpoint of RS or SR. SR is not shown, it's not drawn, but you can, if you had this in front of you, you can do it as a sketch. Okay, Q is the midpoint. So we are not calculating the midpoint. We are calculating the other coordinate at S. so that Q is the midpoint of RS. So the x coordinate at R is -6 plus that x coordinate at S that we need to solve for, divided it by 2, that's going to give me 2 because Q is the midpoint. And then when you solve for that, you get x is 10. Okay, so I see some of you said 2 and added it to -6 and then divided by 2. That's not quite right. Okay. And then the other one is -5 plus 1 divided by 2 is equal to the y coordinate of the midpoint, which is 1. Sorry, I'm doing it incorrectly now. There we go. -5 plus y is 1. Okay, and then y is going to be 7. Okay, well done, everybody. I think some of you just made a small calculation error. So 10 and 7 are the coordinates of S. Excellent. Right, let's see. We can finish 3.5 quickly. Determine if PR is perpendicular to RQ. How will we know if PR is perpendicular to RQ? We just did it in the previous question. What do we need to look for? Pop it in the chat if you know, or raise your hand and unmute if you want to. What are we going to look for PR to be perpendicular to RQ? So Yenzi remembers about the reciprocal. Yeah, there must be negative reciprocals of each other. Yeah, the same answer. Okay, so let's quickly do the gradient of PR and then the gradient of RQ. Work that out and then we can check if they are perpendicular. Gradient of PR, gradient of RQ. Yeah, Zoom user. Nishan, nice. Just careful, it's not a plus, but a times. Sibongamuso, we are not doing parallel lines, we are doing perpendicular lines. Okay, so calculate those gradients and let me know what they are. Since I'm feeling so lazy today, I'm just not going to work it out. I'm going to wait for the class to do it. Name is Coco. So you guys better be right because I'm not working it out.
Wow, Miss Marlies.
Yeah, if you multiply them, they must equal -1. Okay, pop your answer in the chat. Of course, I'll work it out. I live for working out the gradient. Come, grade 10s, we can do it faster than this. Gradient of PR and the gradient of RQ. Remember, we have the gradient of PR already, so be smart about it. We've worked out the gradient of PR already. It's -4/3. Let's get the gradient of RQ. Okay, guys, so what are we saying? Are these lines perpendicular? Let me know. Right, so the gradient of PR we worked out in the first question already, so we don't need to do it again. That's -4/3. And then when we work out the gradient of RQ, we get 3/4. And then when we check, we get -4/3 times 3/4 gives me an answer of -1, or you could have spotted that they are reciprocals and the one is negative. So they have opposite signs, one's positive, one's negative. And therefore we can say PR is perpendicular to RQ. Alrighty. Okay, this is a very nice test question. Okay, I did actually get it off an old test. So let's see. We've got some more questions here, but we are almost out of time. What I am going to leave you with is a slight little challenge that I want you to take a screenshot of this question. It's actually a worded problem. It is, it's more in the realms of, you know, like a proper extension question. So take a screenshot of this, and then I want you to go work on it before Thursday as your sort of homework. It's the first time I'm giving homework, Miss Coco. I'm such a nice teacher. I never give homework. Okay, so this is your homework to go and challenge yourself and work on this problem.